In this tutorial, we're going to take a look at three examples, three graphs, and naming features of a parabola, where the vertex is, whether it's a max or min, and then where that maximum or minimum value occurs. The intercepts, both x and y, and what the equation of the axis symmetry is. And then after that, we're going to take a look at an example of modeling some quadratic data. I'm going to show you an online tool called Desmos. It's an online graphing calculator, but you can also use it to input data, graph the data, and then we're going to model that with a quadratic equation. So let's start with the features of the graph. So this is the first one here. We're asked to state these 6 things. So the vertex is this highest or lowest point, in this case the lowest point. So the coordinates of that vertex would be it's to the right 2 and down 4. So the vertex would be at the point 2, negative 4. Since this parabola is said to open up, so it continues going in that direction, it's said to have a minimum value. So, and the minimum value is the x-coordinate of the vertex. We think of the y value as how high or low the graph is. So what this minimum value of negative 4 means is that's the lowest of any of the y values for any point in this graph. So we say the minimum value of this quadratic relation is negative 4. And then the next question asks where the minimum or maximum value occurs. Well, it occurs for an x value of 2. If x is 2, we get that lowest y value of negative 4. So the where is the x-coordinate of the vertex. The minimum value or maximum value, take a look at a couple of those in the other examples on the next page, is the y-coordinate of the vertex. Now the X-intercepts, is where the graph crosses the x-axis. So there's 2 of them for a lot of graphs, not every single one. And so this point here would be 0, 0, and this point over here would be the point 4, 0. You might sometime have a teacher say the X-intercepts are at 0 and 4. They're normally quoted as full points, but some people might just say it's the number 0 and 4, the actual number on the axis. The y-intercept is the same as one of the x-intercepts for this graph, because if it goes through 0 on the x-axis, it also goes through at 0 on the y-axis. So the y-intercept is at 0, 0. There's always only one for an upward or downward opening parabola, one y-intercept, but there are often 2 x-intercepts. The equation of the axis symmetry, this is the axis of symmetry. It's the vertical line that goes through the vertex. So if I were to reflect the graph in this, the parabola would look exactly the same. So it's said to be symmetrical about that line of symmetry. And the equation of the axis symmetry is x equals 2. It's always x equals the x-coordinate of the vertex. Also, if we were to plot a few points, like for example, this point right here, that's the point 2. I'll show you why it's x equals 2. That's the point 2, 3. Down here at the vertex, remember that's the point 2, negative 4. And I'll plot one more point. Let's say this point right here. That's 2, 0. Notice that every single point, maybe I'll do one more. That's 2, 1 there, over 2 and up 1. Notice that every single point that I plot on that vertical line has an x-coordinate of 2. So that's why the equation of that line is x equals 2. The line x equals 2 is the collection of all points whose x-coordinate is 2. So that's why it's a vertical line going through 2 on the x-axis. Let's get rid of that. And we'll go to the next one. So graph number 2 here, we're asked where the vertex is. So the vertex is that point right there. So we go over 1 and up 9. So the vertex would be at negative 1, 9. This is said to be a maximum value because there's a highest point in the curve. The parabola is said to open down. So the maximum value would be the 9. That's the highest of any y-coordinate on the entire graph. And it occurs where x is negative 1. Again, the x-coordinate of the vertex. That's where that point happens. There's the highest y value is 9, and it happens where x is negative 1. The x-intercepts are these 2 points right here and here. So they would be at negative 4, 0 and 2, 0. The y-intercept is this point right here, so that would be the point 0, 8. And the axis symmetry would be this line here. So it goes through -1 on the x-axis, or the x-coordinate of the vertex is -1. So the equation of the axis symmetry is x equals -1. Last graph, number 3 over here. This is the vertex, so to the right 2 from the origin and down 3. So the vertex is at 2, -3. Again, this graph opens down, so that would be a maximum point. The maximum value is -3. That's the highest of any y value on the entire graph. And it occurs where x is 2. So the maximum value occurs where x equals 2. Again, the x-coordinate of the vertex. Now, the vertex is below the x-axis, and it opens downwards. So this graph will never ever cross the x-axis, because it does keep on going down here, but that's the highest y value, and the highest y value is -3, so it can never get to cross the x-axis. So we would say there are no x-intercepts. Now there's always a y-intercept somewhere. The y-intercept would be this place right here at -7, where the graph crosses the y-axis. So the y-intercept is at 0, -7. And the axis symmetry looks like this. Again, right vertical line through the vertex. That crosses the x-axis at 2. So the equation of the axis symmetry is x equals 2. Now, this is the example where we're going to model some quadratic data. So I'm going to pause here for a moment and open the Desmos application online. So here's my Desmos graphing calculator online. Actually, maybe let's show it from the beginning. Okay, so it's just at www.desmos.com, and so if you click on Start Graphing, you get where I was just a moment ago. Now, this is where you could type in some function, and we'll get to that in a moment. I want to input the data, though. We've got this data here, and we're going to find an equation for it. So if you go into the plus here, and see, this is where I get the table feature, and so I'm going to type all these numbers in. So 0, and I'm going to just down arrow, so 0.5, 1.0, etc. And so, and of course, this would be 2, and then 8.025, etc. So I'm going to pause the video and just type the rest of these in. So there's all my data, and so now you can see a few of the dots here. You see some of these y values are a little bit too high for the graph, so we could do this to see the whole thing. You can also go in here and adjust your numbers on your y-axis and our x-axis. Okay, so that's another way you can adjust that too if you couldn't do that by just dragging. You can see all the points now, so that works okay. Now, as soon as I click down here, I get back to where I can type in an expression. So the standard form of a quadratic relation, and I just did the up arrow to get that square, and I'm going to go plus bx plus c. And notice how it's come down here, add sliders. Sliders are ranges of numbers that you can adjust to make different a, b, and c be different numbers. So I'm going to click on all. I guess if I just wanted one, I could click on one of them. So all. So here's my sliders. So, and this is how you can change. You see, I'm altering the value for a here. Now notice that the parabola looks like it should open down, but this one opens up. So if you play around with a little bit, you'll find that if it's a negative number, then it's going to open down. Okay, and so notice what happens when I change b. Oh, that's getting closer. Then it's kind of rotating or on that point right there. And this is the c value here. C is 1 right here. That's actually the y-intercept. So we can alter that a bit like this. So you need to just play around with these numbers a bit until you get the graph close to going through all the points. And see, I've got the shape fairly close there, but I can't go quite far enough with the b value. So if I click on this side of the slider, see it's going up to 10, and I've actually got it at 10. So maybe I'll go from -5 to maybe 20 or something like that. And the step is actually, it's going to go by, you know, 1 or a half or 0.1 or something like this. I'm not going to bother putting anything in for that. So now's when I can alter this a bit. That's getting closer to, now I'm not quite through all of these points, so maybe what I'll do is I'll take this down a little bit. And it's kind of, okay, if I compare it here, I don't think it's quite steep enough, so I can change my A values. That's what makes it less steep or more steep. So I'm going to get, I'm going to make it close to, let's try -5, see how that works. And the B value here, let's see, maybe a little bit higher. And then, see, it's not quite going through the y-axis the right place, so I'll adjust that down a little bit. You know, maybe a little under 1, something like that. Let's go up with this a little bit. See, it's getting pretty close there now. Oh, that's pretty close. Okay, that's not too bad at all. You know, C could be maybe 1.5 or 1.6 or something like that. That's pretty close. Okay, so these numbers are the coefficients in my standard form equation. So it would be y equals -5x squared plus 15x, and then c would be 1.6. So that's the equation I'm going to use. Now what I've done, so you see my graph here. If I go over here, I duplicated the graph, and there's the equation. Again, those are the same y values, -5, 15, and 1.6 I'm using here. So that's the equation I'm going to use. So that was a determined equation. So you need to just play around the numbers to fit your data. Okay, and you could have slightly different numbers here because this isn't a really exact science. It's pretty close. Okay, but somebody else could use slightly different numbers here and still have a graph that's going through or very close to all the points. So B here asks, from what height was the projectile launched? From the table, it looks like it was about 2 meters. From my equation, this number right here is 1.6. So it's about 1.6 or close to 2 meters. What's the highest point of the projectile? The highest point is this maximum point here, kind of like the those 3 graphs we were talking about a moment ago. And I could actually bring my quadratic equation back here. And you see that point right there, the y-coordinate is 12.85, so it's about 12.9. And 1.5 seconds, this is seconds on this axis, is when it occurs. So that's going to answer C and D. The highest point is about 12.9 meters and happened at about 1.5 seconds. That's the answer to question D here. When did it land on the ground? Well, I actually highlighted over here for this image when I took that snapshot. It's pretty close to 3.1 seconds. See, at 3 seconds it was at 1.4. That was that point right there. So just after 3 seconds, about 3.1 is when it hit the ground. So that's how you can model some data using the Desmos online graphing calculator and create a relation for some data. And that's the end of the tutorial.